Oh, what's up, what's up, what's up? Welcome back. Today we're working on my image to ASCII AI. So the idea is that we want to take a picture, we want to turn it into text. I've been saying ASCII here, with now I've started putting it in quotes. Because image to text AI, you might think that we're trying to describe what's in the picture, right? Like we might want to say like, oh, it is a scene of a island with the sun. That's not what we're doing. We're trying to turn it into a glob of garbage text that looks kind of like the image, right? And so here, what I'm showing on screen is like the dumbest version of that. We no AI involved. We take this image, we take it into like small samples, so you can see like this red box I'm clicking around is like the size that we're looking at, and we just say like, how bright is that area? And for any given picture, we're going to see we're gonna like look for characters and sort them by how bright they are, right? Or sorry, how far off from the brightness level of the scene that they are. So here we see something like kind of gray, and so we have pictures that are like kind of like, you know, maybe like 25% filled in. And if we go down to the bottom, things that are like really bright will have like the lowest scores, and things that are really dark should also have pretty low scores in comparison to things that have like some mix. And that like depends, you know, we can go over to something, maybe that was like the darkest area. Anyways, point is, then we get to like something like this, where we've kind of got this like garbage representation, but it looks like it kind of resembles the image, right? And the thought is we can do better, right? The thought is, if you have a sample, and in that sample you have like something that looked like this, right? Theoretically, surely we should be able to figure out that picking an X is good for that, right? And so we're trying to get something that could have like basically sub-glyph accuracy is what I'm going to start calling it now, where the glyph is like what we're going to render here, but we could match the shape and color of the image better than by one glyph at a time. And so you start thinking about that, and you start going like, well, okay, say we have like a grid of 5 by 5 pixels, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, right? And say we have like our little X in there, so we'll just color that in. Boom, 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 boom. But let's say that it's like not like fully black and white, right? Maybe there's like, let's just say 255 brightness values that each of these could be, right? So that's 255 brightness values. And then we have some number of pixels here. So we're going to say there's 25 pixels here. So 25 pixels here. So times 25. Sorry, each pixel has 255 options. So yeah, times 25 options. And then you have to compare each pixel with each character that you render. Or sorry, you have to compare each of these images with each character that you render. So you end up doing like some sort of like complex number of pixels times number of glyphs operations if you wanted to like compare each pixel. But you might want to do something like more advanced than that. And so the idea is that like we can maybe do something that's like much simpler. We can like come up with like a complex metric that will give us the right answer. But then compress that complexity down into some neural network, right? You can imagine that instead of doing whatever expensive operation we're going to do, you could just stick it in a neural network that basically says, I'm going to look at all the pixels like this, like each one of these is one of the pixels. I'm going to feed that into like some like hidden layer where each pixel goes into like some compressed form. And then we're going to take this guy and use him to decide. We're going to compare him with each character. So this is going to be like A, B, C, D, right? And the idea is that turns this into like O of M times N into O of M plus N. And the thought is probably that's faster. Hand wavy. And probably we can come up with a neural network that can do this effectively, and probably, right, I assume that some characters are not going to look at like the whole input space, right? So you might actually be able to like zero out some weights and like prune them and get even faster. So that's what we want to explore. And today's topic is trying to basically come up with the expensive function that says that this is X, right? Right? How do we get from here to here? because like we need to come up with a correct answer to train the neural network, but that operation can be as expensive as we want it to be, as long as it comes up with like a good result. And so that's what we want to do today. So I think what I want to look at is, first we need to be able to like quickly compare different metrics. So I think last stream we came up with a different one. Hold on. Let's see if I can find it. Last stream, we tried very briefly changing our metric to saying, instead of checking the brightness of each picture or of each sample, we're going to compare each sample. We're going to subtract one from the other, essentially. So if we went back to our little example here, if we had like a dot here and a dot here, we would end up subtracting each pixel with the equivalent pixel in the glyph. And we'd say like, oh, this one's close, this one's close, this one's far, this one's far. And we'd have like some sort of metric of distance for each pixel. And so that gives us something interesting for sure. And here you can see like if I change my sample, if you look down in this like selected sample area, if I pick samples that have like more or less white with a hard line in them, we end up with a glyph that like matches that somewhat. But it doesn't look like great, right? Like you can tell like this image on the right is like super contrasty, kind of like very blown out, right? Like in the one we saw before, it's hard to remember, right? But the clouds looked a lot more reasonable. The water looked a lot more reasonable. But looking close in, it looked worse. I mean, so one, I want to be able to like quickly flip back and forth between different metrics. Right there, what I had to do is I had to restart the program and check out a new commit, compare that, and then try to remember what we had before, which I actually do have here. But you know, we have to like, remembering's kind of hard. And then I want to look into like, well, what if we took like the two metrics we have right now, which is like just pure difference from one to the other, as well as brightness. Could we like merge those two in some way? And what would that look like? And then I wanted to look at maybe some way to like look at things that are close by, right? So maybe we like look at like this section and this section and this section and this section. Maybe we like blur it or something. Try to get like some sort of like metric that isn't perfect pixel to pixel matching, but like we're in the area, right? Something that looks like that. And then if we get there, we'll have to think about what to do next. There's other paths we could go down. We could go down like color. We might have like some like other ideas of what's like a good like metric for this. Yeah, we'll have to see when we get there. So I think step one is just adding support for multiple metrics at once. So let's do that. So that's intro done. And what we're gonna have to do is probably I'm just gonna add like a drop down like here maybe. And that drop down is going to have the different loss metrics. And when you select them, it'll just show like the different image and probably like swap out all of these guys below for the correct one. So let's do that. Let's like kind of like mock up the UI there a little bit first, and then we'll like plug in the back end after. So give it a sec. I just got to start up Michelle. Yeah. Here we go, and then we will go to, the HTML. And underneath the images, which is here, we're going to like select, I think is the word for this. And you have like option, how do you do select in HTML? HTML select. I actually don't remember. Option value equals blank with the text in it. So I guess we can do like value equals test, and we'll do values test2, just so that we can have like look at what that would look like. We actually have to run our server. I closed it by mistake there. Even the best of programmers don't know option. Oh, I think it's just like probably like a memory thing, right? Certainly if I did it more, I would remember. Okay, so we have like our little drop down here, and maybe we should also add like a label for it. So how do I like label HTML? If I remember correctly, you can say like you have labels for things. Label tag defines a label for several elements. So I don't really label this. I probably just write like div here or something. I don't know. Maybe p, I don't know. And we'll just say, maybe this is like actually like a header. That makes more sense. So we'll just do h4 like I've been doing for everything, which I think is semantically wrong. I think probably you're supposed to use like your top level header and then your secondary level header. And if you want it to look different, then you style it accordingly. But I've just been using fourth level header as my top level header because I like the way it looks better. But anyways, we'll call this what? Label metric. Labeling metric. How about it? Okay, so we have that, and then we can come down here, we can select it, boom, easy. And then in JavaScript, we're going to have to pay attention to when we change that and do something with that action. So how do you like JavaScript monitor select option? So well, this isn't what I want. JavaScript. I can spell. RIPT, on option select. On change. That sounds right. So they have select on change, yeah. So then they get the selector, not the option, probably. So here I could do select ID is equal to loss selection, not loss, label metric selection. And then we can say, what are we going to do on label metric selection? On label metric selection. So this is going to take in something, some sort of like change event, I guess. We'll call it EV for now. And then down here, we're gonna like, first we'll just start by logging. And then down here, we should say document get element by ID, label metric selection. And let's see. What are we doing here? On change is equal to on label metric selection. Sure. That seems probably like what we want. Refresh. Look at the console. And swap it out. And we are seeing a change event come in. Pretty sick. Hey, did you go to college for this? I went to college for computer engineering, which was a lot more of like electrical engineering and like operating systems and stuff, more than like, I didn't do any web dev in college. Let's just say that. And I didn't do any AI in college. So it's, you know, they taught us how to program for sure. I already kind of knew how to program before that. So I would say it was very useful for breaking into the job market, but personally, I didn't think it was useful for anything I worked in. I think I took like maybe one course in all of university where I was like, that was relevant. But it's always only because I had already done so much before. So I would always, of course, always say you should go, if you have the option, go to school for it. But I also think that a lot of the learning comes on like your own time. DSA emphasis? Digital signal analog. Nope. What's DSA stand for? Already 2 years experience as software dev. Yeah, okay. Then I would bet, we'll see if you feel the same, but I would bet that 2 years of experience of software development is way more than the college will give you in terms of like ability to do the job, okay, and like understand. But I mean, the college gives you a bunch of other experiences too, which are very useful. I want to focus on AI machine learning during those 4 years. That makes sense. I could see going to school for AI being very useful. Like, especially if you do like a lot of math. Like my math and stats are like pretty bad, and I kind of wish they were better. And school can accelerate that for sure. All right. What was I doing again? I was looking at these change events and on label metric change. And I wanted to, when this happens, we're going to have to, well, there are two options here. One is we could ask the server to reprocess everything with that label or with that metric, or we could always send all data for all metrics and just swap them out. Or we could cache them and resend. Probably resend seems reasonable. So let's go back to our server side and all of our outputs here. So we have image output, sample outputs. We'll probably just add parameters to them to say which labeling metric they want to use. So let's just start with one for now. We'll start with just this big output on the right. And I want to be able to swap between two labeling metrics and pick which one. Which means that actually before we even get there, we're going to have to get a list of what the available metrics are to fill the list. So we're going to have to ask the server for label metrics. And here we're going to say, that's going to call some function, get label metrics, which we have to make. So let's just copy paste something to start from, get label metrics. He's going to return some JSON. And for now, let's just return a raw list until we figure out how we're going to store it on the server side. We'll just say JSON dump string. Oh, actually, I've been doing dump string and then writing, but you can actually just dump it to a file. Because the output of this guy we write to a file-like structure. I didn't think about that until right now. So you could dump, let's just for now start with two strings. So we'll say the first one is brightness, and the second one will be diff. And dude, this fucking, I have to at some point disable that pop-up because it's fucking annoying. And let's see if that works. Let's see. So we're gonna go to label metrics. And a bytes-like object is required, not string. Did I get the order of operations wrong? Or maybe that's just not legal like I thought it was. JSON dump. He takes an object and a file pointer. And a file pointer should be anything that supports write. So why doesn't it like that? I would have thought that that's legal. Oh, because we have to... hold on, let me look again. Oh, because JSON dump outputs strings, and the file that we're the output of the server expects expects bytes, not a string itself. Can I ask for that? No. Ensure ASCII, skip keys. All right, fuck it. Fuck it. We'll go back to what we were doing before. We say options is equal to this JSON dump, but we're going to do a dumps to a string. And then we're going to write to self w file write. But we need to send the options as a bytes thing. So we type in code to go from UTF-8 string to array of bytes. And that should work. That should work. And so now if I go here, I get brightness and diff, which means that on the JavaScript side, I have to execute that call. So we'll say let label metrics promise is a fetch of label metrics. And then we have to turn that into the JSON that came out of it. Add this guy here to the label metrics promise, and here also label metrics. There we go. Not Yeah, here we go. That's the different metrics we're allowed. And so then somewhere here, we're going to have to say, here is our label metric selection, or label metrics element, we'll call it. And presumably for each element, we're going to have to create an option with that value, I guess. Sure. And I guess there's like two things here. There's the like string that we're going to display on screen, as well as the one for like using as an ID when talking to the server. And we can just make those the same thing by we'll just by convention not capitalize, because IDs in my head don't have capitals, and so we're just going to stick with that. And so then we're just going to create an option for each one. Self, or we're going to say document our for label metric of label metrics. Yeah. Are you planning on supporting color? I think so. I have to think about it a little bit, right? Because it depends on where I want to use this, right? If I want to use it in the terminal, then it makes sense to support foreground background colors, because most terminals will support arbitrary foreground background colors. But if I want to like make a meme and copy paste it into a chat with my friends, then in that case, like color is bad. And so I have to think about how I want to structure the problem so that both work. We might have to construct two neural networks, one that predicts color and one that doesn't. Or maybe there's a way to like structure the problem so that the color can be like an add-on afterwards. But that's I've definitely been thinking about it. But I think first I want to get something that works good with no color, and then we can move on to color after. Okay. Do I have to say let here? I can't remember. Well, console log label metrics. I don't know shit. I don't know shit. Refresh. So that seemed okay. Looks like I don't need to write let there. And then we're going to say document create element option. The const option is this. Option.value is going to equal the label metric. And also the inner HTML is going to equal the same thing. Sure. And then we are going to, before any of this, clear the label, or like the options from like our placeholders test and test2. We're just gonna say fuck you. We don't need any of that, and we're gonna put our own thing in there, and then we're gonna say label metrics lm.append child option. Okay. So now when I refresh, he gets cleared, but he doesn't like that I misspelled elem by elemen for some reason. For some reason, I just wrote something completely fucking different. And now we have our two options, which is pretty sick. Why is it so slow when I click? Who knows, but that's fine. And then on change, do we get like the option value as like one of the things in here? Explicit optional target, target. How do I see like which thing is selected? Certainly there's like a change event Mozilla documentation. All right, so on change event, event target value. Okay, so let's print that and see what we get. So on change, we look at event target value. Console log that. Refresh. Womp womp. And so here I should see, oh my god, let me click, please. It's probably like rendering all of those like characters below, and that's taking time. But okay, there we go. So we get the value. Sick. And now we should be able to like swap out all of our images for I guess we're gonna refetch the scores for that loss metric as well as the output image. So let's start with the output image, and we'll say are we doing anything with that output image anywhere else? I think no. I think no. So here we have output image. He doesn't even have an ID, so ID is equal to output image. Cool. We don't have to worry about anybody else fighting us for that, so that's fine. We can just say output image. Oh, JavaScript usually doesn't use underscores, right? Do they like JavaScript snake case versus camel case? What do they use? God, I don't care about client recommendations. I just want to know, like, what would people normally do? I guess, like, all of the functions and variables I'm seeing in the inspector, right? If I go here and I type a dot here, everything I see in here is camel case. So I should just follow that convention. Except for, like, these, like, for some reason, they're, like, events aren't camel case. They're just no casing at all. I don't know, who fucking knows? But it does look like they're generally using camel case, so I should match that. Output image, just for consistency. Not that it fucking matters, but consistency is nice. Okay, so the output image is document get element by ID, and we get the output image. And we're just basically going to say that why did I copy paste that? Output image source is going to be swapped out for the specific loss metric. So we're going to say output, and we're going to add a query parameter that says metric is equal to, and then we're going to add in EV target value. Fucking easy. Easy. Which means that in our server, when we look at output, we're going to have to support different outputs here. So we're going to start with the query parameters. And then what? Get image output is going to have to say, he's going to have to extract the metric. So he's going to say self.path, and we're going to take the number of characters in this and just look it after. So this is 8 characters. Boom. Print metric just to make sure. And setting the response headers as image PNG makes sense still. But now, instead of output image, maybe what we do is we store here in our server the like output image, but really we should maybe store like output images. And this is going to be like a dictionary of string to NumPy or torch tensor. I think it's capital T here. I think. Which means from typing import dict, I think. Does that all work right now? Which means that when we create our output image here we're gonna have to iterate over our like available loss metrics. So we'll say loss metrics is equal to diff and brightness. Cool. And then we're just gonna say for loss metric in loss metrics, I think. My brain's starting to get like a little bit confused by like Python versus JavaScript syntax. They're getting like merged in my head, but I'm pretty sure it's in here and of in JavaScript. It's also in JavaScript, but the in JavaScript means something different than the of in JavaScript, and like the of is the one that you actually want, and the in just does something like fucking unexpected, like everything in JavaScript. Says someone with little experience. says someone who has no idea what the fuck they're talking about. Okay, but for each loss metric, we're going to have to get an output image, and here we're going to make a dictionary of output images. And for each one of these guys, we're going to say output images loss metric is equal to output image. And all we have to do is actually this get samples and labels for image is now going to have to be here. And we actually don't want to get samples and labels probably. We probably want to get the samples and the labels independently because we want to pick our labeling function. So what does this guy do? He looks for the data. We don't actually care about the input data because we do some like conversion. He does conversion into the like glyph space. So for context, we import an image that might look like this, right? We have like the sun over here and like our little mountain. And like, you know, this is like the image that we're using. And say that we want to like chunk this into like 100 things over here. So each one of these samples is going to take like 1/10 of the image. 10, 5, 2, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 or something, right? Sorry, let's say we want to go 10 across, not 100. Now, each of these is going to have some sort of pixel width. So if this like whole thing is 1620, which is I think its width, each of these is going to be 162 pixels. But the width of the glyph might only be like 50. So what we might do is we might resize this whole image down so that each of these samples is 50. And that's where we actually do our like comparison with the glyph, right? So we like look at this section that's 50 wide and we say, oh, that's like, you know, part of the sun or something. Part of the sun. And then we say like, well, doesn't H look kind of like that? And we like compare those two. So we're going to have to say like, look for the sample in this space and then get the labels for that essentially. So here, loss metrics probably are going to have like a labeling function associated with them. So we actually might want to do pairs of diff and label generate labels. What do we fuck? What do we call it in here? We call it get labels for samples. And so we'll say get diff labels for samples, which doesn't exist yet, but we'll make it. Actually, for now, we'll just like get labels for samples because that already exists, and just so that we can like get something that runs, and then we'll swap out the actual functions later. Okay, so we have two functions for two different loss metrics, and then here we need to say for loss metric loss function in each of these, we are going to, let's see, we're gonna like extract the samples for comparison. Which is something that we have to do many times in here, so we must have a way to do it easily. Get sample output. Sample to sample for comparison. Get labels for samples. Okay, that's not quite right. We have get samples and labels, which takes an image and chunks it into the right amount of width and height. We have number of Y and X samples already available to us here. Sample height comparison we already have. So we should just be able to actually say extract width height samples here. This looks a lot like what we want. And we have the sampler image for comparison. And then the actual two arguments before that are going to be the sample width, so sample width comparison and sample height comparison. Okay. So here we have data for comparison, and then we should be able to say loss function, which again isn't, we're calling it loss, but it's not really loss yet. This is label. So anywhere we say loss right now, let's just replace it with label. Okay, there we go. And we call the label function with the data for comparison, as well as our glyphs, like a list of all glyphs that we have available to us. So glyphs, self, sampler, is it not? Oh, not self, we don't have self. That's why, sampler.glyph cache, there we go. And here we can say that the labels is this, boom. All right. So now we need extract with height samples. And I think that works. So now we have a dictionary here of name to image. We have to pass, each of these guys has to be multiplied by 255, actually. Because they're in like 0 to 1, and the image library expects 0 to 255. Here we pass in output images. And I think everything else probably starts to work. In our HTML, probably we won't see an image until we switch our label matrix, but that's okay. So he doesn't like this reshape, which is at image sampler that comes from 216 in main. 216, what are we doing? We did a argument of type float, which should be int. Oh, so we can just int here. And otherwise, it looks like it's run. And probably if I go here and refresh, we're going to see something not work. Yeah, this image doesn't exist, but then if I select diff, does this guy get updated? Inspect. His source is output, which isn't valid. But now his source is metric equals diff. But now we're still trying to use the output image somewhere. Server output image. Aha. Because we didn't actually update this. So it should be output images with the metric. Let's try that again. Let's try that again. Give it a sec. All right. And then I switch this from brightness to diff. And he doesn't like key error metric equals diff. Oh, fuck, because I forgot to actually parse the query parameters. So where do we do that? Parse query params. Right. I was actually supposed to parse the URL and extract the query parameters and extract one of them specifically. Which I just wasn't doing, because I wasn't thinking. Get output. No. Search for output. Get image output. Here I parse the URL. Like this. Get the query params, and then say metric is equal to query params metric. There we go. And put a 0 on there. All right. So now I should be able to say here, output metric equals diff, and hopefully, there we go. We get an image, and when I swap these guys, do I see something interesting happen? Maybe my browser will crash. There's too much going on, too many images. So I switch it here. Okay, here we go. So now I can switch them. So his initial one is fucked, and also brightness doesn't seem to be a key here. So maybe I spelt it wrong down here. Brightness. Oh, it's because I didn't spell brightness in the list here when I return the list. So these options should actually come from the available options to us now. So we can say, what we should do, take the keys of our output image dictionary, self server output images keys, and then turn that into a list. And hopefully now we see brightness instead of brightess. Very subtly different. Dude, my browser's losing its mind. But that seems to be working now. We can inspect this element and just make sure that we go from diff to brightness to diff. Everything's working okay. Which means now all we have to do is actually generate the different loss functions, which would be fucking easy. I found an old C++ graphics engine I wrote, and I'm just fixing it up. Boy, I used to write bad code. I still do, but I used to too. Dude, that's one of those things where, like, I feel like you should look back on what you wrote, and if you don't feel like it was bad, then you're not progressing. And I felt like that's so much for like the first 5 years, but I get concerned sometimes when I look back on code I wrote 5 years ago. I'm like, damn, I like what he did, because that just means I haven't got better. I think that looking back and being like upset is like just better, because it means you're progressing. Okay, what was I doing? I was trying to use those different loss metrics now. Okay, so somewhere in all of this. So when I look back at all of my codes, I should be safe from that. Yeah, exactly. I think you're in a better situation than I am. Your learning's good. Improving's good. Okay, so right now, diff is our normal one, and we're just going to have to create a new labeling function for brightness, which will just be pulling back the one we had before. So here we have get labels for samples. And this guy is actually the same, because he's calling a scoring function and then taking the minimum. Which idiot coded this? Get blame, it was me 2 years ago. Dude, the amount of times I've done that. Get blame is like, it's very, like, it's toxic when you first start asking who the fuck did this and check it. But damn, is it humbling when it's always you. So we need, like, I guess actually different scoring functions. So our get labels for samples should maybe take in an optional scoring function. And we'll just default him to our default scoring function. But we will allow a custom one. Seems reasonable. And then we'll take our scoring function and we'll copy paste it and we'll completely rewrite it. So almost like we shouldn't have copy pasted it at all. Get brightness scores for samples. This, boom. And then what do we pass in? We'd say that the samples for comparison, we're gonna sum them on dimension. Let's just fucking look at what we did before, because we have this code in existence already, and it was this. So we'll just copy paste this guy back out. This is all we need. So we sum up the samples, we sum up the glyphs, and then we just say which one's closest. Reasonable to me. Reasonable to me. Yeah, and then here, the brightness one is going to be, we're going to take in samples and cache, and we're going to call get labels for samples with samples and cache, and with the scoring function of get brightness scores for samples, which we need to import here. Get brightness scores for samples, which, oh, dude, once again, dude, there are so many common typos for me now. Brightess instead of brightness has already happened like 3 times today, which is crazy. All right, I'm not really perfectly convinced that this is going to work, but we'll just refresh and try it, and then we'll find out. Okay, so it looks like oh my god. Brightness? Okay. Oh, diff, brightness, diff, brightness. That's kind of slick. That's definitely kind of slick. That's pretty cool. You can definitely tell that, like, the diff version has definitely improved, like, details in the mountain. Right here with the brightness, it looks like kind of like shit. And with the diff version, you can kind of see like this shape in the mountain kind of shows up. But if we reduce the sample width, actually, which is kind of interesting, I'm pretty sure that the brightness one starts to look better, if I remember correctly. Hopefully nothing crashes from this. So here we go, brightness. Do I have to refresh maybe? Brightness? Yeah, there we go. So now, no, I think diff still looks better. My only problem with it really is the like over contrastiness of it. Okay. So I think we said add support for multiple metrics at once. That's pretty cool. And let's commit that actually. Git checkout-b December 29th. And we'll say checkpoint. We'll call this a whip work in progress. Checkpoint multiple labeling functions supported, kind of. I say kind of because we're not actually changing this like scoring, these scores down here. But we'll get there. What I'd like to see, fuck, we should probably fix that because I think that this down here is actually also going to be very important. So I think that's probably easy to fix as well. I want to be able to see like what almost won in the cases where something went wrong or like we don't like the way it looks. I do kind of want to see that. So what does that look like? So here in all of these sample input, output, and metadata ones, we're just going to have to also inject our loss function, or our like labeling metric, I should say. Oh, and I just don't want to do that. I don't want to do it. So maybe we'll just live with it being shit. We went through all this work, and we're just ignoring it, which is really bad, but that's okay. That's okay. Let's try now. I wanted to look at a like combined diff and brightness one to see if you can like get something that's kind of reasonable. So we'll call it combined, and we'll call this get combined scores for samples. Okay, this needs a comma, this needs a comma, and then here we say get combined scores for samples, and we just make that function now. Which should be really easy. The combined scores should have what are his, so he's just going to call both, I guess. Get brightness scores for samples with samples for comparison and glyph cache. Scores equal this. And then scores plus equals get labels for samples. Yeah. And then return scores. And let's see what happens if we do that, which requires a server restart. Temporarily, I'm going to disable some of this code that I think is slowing us down. Because if we're not using all of that stuff that's slowing down the browser, we might as well just not do it. And he doesn't like this for some reason. He does not like this. So are these not, do these not take the same inputs? Get labels for samples. Oh shit, it's, fuck, get glyph scores was what we called it. There we go. All right. Let's try that again. Try it again. We'll give it a sec. God, this is taking a long time. Holy shit, that's slow, man. What's anything like now? Refresh. Oh my god. That's really slow. Holy fuck. Okay, so what doesn't he like now? These label, this guy is not working correctly? What the fuck? Oh, because I commented out something I shouldn't have. There we go. So here we have the combined metric, brightness, diff. Combined looks maybe the best of the three. For sure, like using some sort of like doubling up. It does seem to be having like a interesting effect. It might be interesting to maybe, how do I say this? Like weight how much it's used. Maybe. It does look the best of the three so far, though. Like, by a lot. And what's our font size here? I think our font size is 12. Can we try with like a 24 font size just to see? See if bigger has the same issues. Okay, so we've combined. Oh, that looks like shit. Diff. That looks a lot better with less resolution, which is pretty interesting. So this actually looks way better than this. But maybe that's just a result. Like maybe like the optimal solution for something with such big glyphs is like not okay in general. Maybe. Fuck. And now we're back at the point where I actually want to look at individual things. So I think we are going to have to add support for this like sample scoring. What kind of neural network is this? Right now, it's the shittiest neural network of all time. In fact, right now we're not even looking at the neural network, just the label generation. But right now, our neural network is essentially just pixels is our input. So like if you had like a 2x2, you'd have like 4 input nodes, 1 for each pixel. And then we have characters as our output, right? So like if we had like A, B, C, D, we'd have 4. Right, this is A, B, C, D. This is this pixel, this pixel, this pixel, this pixel. And then what we do right now is we just connect our inputs to our outputs directly, which is really shit, right? But for our initial metric, which was just brightness of the image essentially, or brightness of the area, that was a good enough neural network, right? Because you can imagine that all you need in that case is to like sum up like the brightness value, and then you should be able to select the right character based off of that. But eventually we're going to want to improve that. So I think what we're going to do first is we're going to try just like a naive hidden layer, a couple hidden layers. But I think that I would bet that you could get a faster network with equally good results by using a CNN to like downsample the image intelligently, so that you're like actual, because like if say you like threw a hidden layer in here, you have like M characters and N pixels. If you have like a constant number of neurons in here, you'd be of like big O of N plus M essentially. But I think that if you used like some learned convolutions on the input pixels, you could probably get this down to like big O of N over something plus M. Like I bet you that like you could intelligently downsample with convolutions, but we haven't. We're always off from exploring that probably. Okay, so I did want to start going back and like using these sample input and output things. So at the very least, let's add support for the box drawer again, and the ability to get a specific sample in the UI. Thanks for the explanation. Oh, no sweat. No sweat. Okay, so here when we get a sample output, we run our label for sample. And I guess all we have to do here is we have to extract which metric that they want. So we will just also say, we will return a metric here. And we will say metric is the query params metric. And who uses this guy? Sample input doesn't care. Sample output definitely cares. And the metadata definitely cares. So currently, if you grab an image of font and shift it a pixel sideways, it will not be able to find a perfect match anymore. Yeah, probably. Also, our font rendering is shit. Like, I do want to clarify that. Like, we have, what we're doing right now is we're stamping. We're basically saying that each character has a fixed width and height, and we're just stamping it into the center. And so some things, like, don't fit that correctly and like run off the edge and stuff. But we'll fix that in the future, probably. But yeah, you're right that right now, if we grab an image in font and shift a pixel sideways, it will be like, it will think that the correct, like, if you took, with our metric of pixel difference, I think you're right that if we took this and we took our X and we like just moved it over like a little bit, like, so it was like this, we would like render the X in here and be like, wow, that's the worst fucking answer of all time. That's so bad. It doesn't match us at all, is what we would say. And that's like obviously not true. And I think that there's probably some way to fix that, but for now I just wanted to experiment a little bit. So let's get back to trying to get these metrics to work correctly. So here, when we call scores, instead of calling get glyph scores for sample, we're going to call our function that we defined down here. Somewhere we said, here are our label metrics. And so actually, I guess it makes sense for these label metrics to be a dictionary where these guys look like this. Which seems reasonable. We need to delete some brackets here as well. And then we will just pass the label metrics into our server. And where do we pass that? Right after the output images. So here we'll take in the label metrics. And then we'll store them. Self-label metrics is equal to label metrics. And then when we get the sample output, we will just use that metric. So self-label, self-server label metrics metric. And we will do the same here. No. This actually goes, this is a parameter, sorry. Self server label metrics metric here. And then down here we have to do the same. Self server label metrics metric. And I think that gets us like almost everything for free. It just means that when we click in our JavaScript, we're going to have a bunch of like calls that no longer work because we're not passing in the metric as one of our query parameters. So sample input here doesn't need that, but the output does need the label metric here now. So we're going to say plus and metric is equal to metric, which means where class is this? Box drawer? Sure. We will store the metric. No, we'll just fuck, I don't know. We'll make a function get label metric here, and he's gonna say document get element by ID label metric selection dot value. There we go. And now we can this say where we call this. We say plus get label metric, and I hope that works. I hope that works. And this guy also needs to do the same thing. So we say plus and metric equals get label metric. Jesus, maybe. I don't know if that's right. Which means that probably the label metric stuff needs to happen before our box drawing. And I'm like, maybe like 30% on if this will work at all. I'm 0% on it working, actually, because it doesn't. How do you like iterate a dictionary in fucking Python again? Values? No, it's not keys. It's not values. There's like, is there a third one that's both key and values? Items, that's the one. I don't know why like the default iterator wouldn't do key and value, but I'm sure there's a reason. There's always a reason, I just don't know it. There's always a reason. Okay, refresh. So if I select brightness now, and I click here, these guys aren't working. what kind of data set are you using here? Right now, as with everything so as with everything so far, our data set is shit, and it is one image. It is this image. We've only ever trained a neural network to predict characters for this, because the idea is the reason that you would want like a larger data set is to avoid overfit, right? But we haven't even decided what our metric for like success is yet, right? So trying to optimize for like overfit when we don't even know if the value itself is good is like we need to figure out the data first. I think that like my thought as just a guy, right, on the internet writing code, kind of blind, is that there's no point in trying to optimize for something until I think like the data is like the most important thing for the neural network, right? The architecture, you will find an architecture that works for a problem like this. This problem is so fucking simple, right? In the absolute worst case, you could take like an image classifier and just run it and it'll work, right? And so like before any of that, we need to make sure that like we have a metric that we can generate a loss for that is like good. And so that's what we're working on first. And then we'll go to like network optimization and stuff and like data sets and stuff like that. But I'm like very confident that we will be able to just take any data set and run it through. And especially if our network is really small, which is kind of the goal, right? We want our network to be small as fuck. The overfit risk is like much smaller in that case because there's like less ways for it to cheat, right? If it's only got like 10 nodes, it can't go like, oh, I'm going to memorize this picture because it's just too fucking stupid. It doesn't have like its brain is just too small. But we will eventually have to try to get there. But for now, we will not. So sample input should have actually kept working because the metric isn't important here. The sample output is appending the brightness metric, but it's still broken. So let's see. I guess let's do this. We'll make metric an optional. Okay, first of all, we're trying to convert it to an int and a float. Obviously wrong. And we should make it optional. So we should type, I'm going to assume that this has a get metric none. And if metric is not none, metric is equal to metric 0. And now we should get farther along this path where we will maybe fail after we try to use the metric, but in case we don't use the metric, it should be fine. So we should at least get the like input image working correctly here. Yep, input is correct. Output is not. So what's going on here? We have a metric diff, and let's say we open this image in a new tab. What does he bitch about? He doesn't like something. Get labels for samples, scores.min, dim1, dimension out of range. We only got 0 dimensions. Okay, so let's look at that. Get image output. There we go. And here we are trying to do something with the metric. Oh, no, not get image output, sample output. That's the one. Because sample and image are different, of course, obviously. Sample is sample for conversion, okay? And then here, we are saying get labels for samples, where we are using the label metrics metric, where label metrics comes from this. So this should be get labels for samples. And I don't understand why that wouldn't work. Oh, because we're calling get labels for samples twice, which is just fucking stupid. Oops. So that shouldn't be get labels for samples. That should be get something else. Get glyph scores for samples. Fuck. So it should be get. Oh. I see. Fuck. So we should actually have a new thing. Fuck, this is so confusing. Score metrics is what we're going to call this, not label metrics. Oi, oi, oi. Because we need the scores for each individual sample, for each glyph, which the like labeling function doesn't give us. The labeling function just gives us which glyph was best. We want the score for every glyph, which is like one layer down. So we're gonna, instead of doing this, what we did here, we're gonna say get glyph scores for samples, get brightness scores for samples, which is like the layer down. Okay, and combined is get combined scores for samples. Okay, we're close, we're close. And instead of iterating the label metrics, we'll iterate the score metrics. Yes, yes, yes. Score function, not label function. And here we're going to call get labels for samples with the score function. Yeah. As parameter. Yeah. And then here we're going to pass in score metrics. Yeah. We're getting close. Label. Yes. So now we have score metrics here. And here and here. Except I spelled metric instead of metrics. As usual, I fucked up my typing. And we're so close. So now we should be able to say get labels for samples with the score metrics of metric. Yes. And then on this one, we should be able to call score metrics metric. Yeah. Okay. I'm now at like 60% sure that this will run. If only there was a compiler that would tell me the answer. If only. Refresh. So we've refreshed. Let's switch the label metric. Oh, okay. So let's switch the label metric to brightness and then click somewhere. And then switch it to combine and then click somewhere again. Yes, okay. I think this is working. So we can look at like here. And we can see that like as we move up and down on this combine metric, we are like in some cases like this here, the diff metric is working very well. But in like here, I don't know if that's like what I want. And so like what other options do we have in here? Here we have like, I would think that for this picture, maybe this one down here is like a better option. Which I bet is probably picked if we go on straight diff. Right? Yeah, then they does pick that guy. But in the case of combined, that guy has a score of 177, which is like much higher. So maybe weighting the brightness makes sense. Maybe. Yeah, not sure. Not sure. I think also there's probably something about like how do I say this? This is like two-tone essentially, right? This sample on the left, he is gray at the top and white at the bottom. And so maybe it's reasonable that this like perfectly black thing up here isn't chosen in that case. Right, like, is there a better option in here for something that I think is mostly white if gray is, like, on the brighter side of things? Maybe not. There's a thought here that maybe we should try some, like, tone mapping of some sort. Maybe like, this, like, contrasty look of this guy is actually, like, reasonable given the fact that we only have two colors. And maybe we should be biasing towards brighter or darker in some scenarios. Maybe we should be okay, images that are HDR. What they actually do, I worked at a camera company, so I have like a little bit of info here. You take like a really dark image and a really bright image, and you like stitch them together. But what you don't do is you don't just take the bright image in dark areas and the dark image in bright areas, because like let's say you have like, how do I draw this? Let's just say that we have like dark light like this, right? And you take like a second image at like higher exposure. So actually in here, this is going to be like gray up here, essentially. Gray, dark. And then you want to like see the stuff in the dark, right? So you take a second photo and you draw a line here. And now all of this stuff is gray. And this stuff is just like white as fuck, right? You can't see anything. And if you were to like stitch these two images together, you would get this like weird behavior along this like center line where essentially like this stuff in the image, you want the stuff in the bottom left to look darker than the stuff on the top right. But you also want to be able to see both. So they do this like kind of like weird thing where they try to preserve like local differences in brightness while still having globally everything actually appear kind of approximately the same brightness. Like that's kind of like how you like take an HDR image and you squish it into like, yeah, what you can see. So what you might end up seeing at the end after they squash those two images together is something that looks kind of like gray over here, then like dark gray here, even though it's not darker by the line, and then back to like light gray over here. Like that's just kind of like what you might see, because they want to make sure that like on this line, the transition from the top right to the bottom left like shows a darkening. And so the reason I was thinking about that is because in each glyph, you might want to preserve the like dark to light nature in that individual sample, right? So like on like, let's see if we can find like a good one. Right, like maybe here, treating the top half as like super fucking dark and the bottom half as super fucking bright is like okay in a way if it's just not close to something like over here that is like the same really bright brightness. There's like maybe an interesting concept in there. Not sure. Maybe we could also just reduce the whole contrast of the image. Maybe like lighten up the whole thing. Not really sure. I'm just trying to think about like, how could we like, do we want this to be two-tone? And I'm not really sure what the answer to that is. Like you can see like here it is and it looks shit. Like it just looks bad versus that, which also looks really bad. This also looks bad. They all look bad. Let's reduce the font size a little bit to see if that like changes the way we think about this. Which ideally should probably be like a runtime parameter. Dude, it's so slow to start. Oh my god. So let's try combined. Oh, that's kind of nice. Diff. Okay, so that's interesting. So here, with such with lower font size / lower sample dimension, whatever, I would actually argue that these like this foam here looks like really fucking good. Down here, less so. And I wonder why. Okay. Well, I think we'll just keep all of that in mind. I don't really have like a good feel yet. Let's try, actually, I did want to try weighting the brightness maybe a little less here, right? Maybe we should mostly try to handle the diff, but then just kind of bias it a little bit towards keeping the overall brightness of the glyph instead of like the amount that we are right now. But I'm noticing that this is fucking taking so long to start that I want to try just quickly. We support doing all this stuff on the GPU, so I just want to quickly hack that in. So here we've done this. At some point we did support sample, or like support showing all glyphs / individual samples at different labeling metrics. And now we are at an hour and 14, maybe 35, and we are looking at support GPU label generation, which should basically already be supported. We just have to like quickly bang out a parameter device that is a string. Its default value will be CPU, and we should be able to put in CUDA in there. Which means that here, when we create our image sampler, we pass in our device, which is already exported. And when we get labels for samples, I think everything just uses the sample that we generated. So I think everything probably just comes for free after that one change, I think. Let's see. Probably this will actually crash because I have to, there's like this like, I don't know why I have to export that variable, but it's important. Oh yeah, that was way faster. Way faster. And it worked. That's cool. I like it when stuff works. Actually, maybe not, because when we try to render back to this, how do I say this? When we like extract our outputs, we need to turn them all into like CPU tensors. So anywhere we write like numpy here, we just have to write CPU first. All right. Now it should work. God, that's so much faster. Holy shit. Hot take, GPUs are fast at doing things in parallel. Did you guys know that? That's crazy. Way faster than CPUs, turns out. Okay, right. So easy GPU label generation done, because there wasn't actually that much work to do. And now we want to try like weighting. We wanted to try weighted, what am I trying to say? Weighted brightness, diff metric. Today I learned, impressive demo that you prepared to hammer that point home. I wasn't trying to make a demo, I was just mad. As is usually the case. All right. What am I looking at? I was trying to go back to this like brightness metric somewhere. Sampler probably is where we're doing our labeling. Because of course sampling the image is the same as generating the labels, obviously. It should go somewhere else for sure. And let's just say that we multiply the brightness scores by like 0.2. I don't know. Right? Just to like make it so that the brightness is still having effect, but like not such a strong effect. Right? We want to weight towards the diff version. Missed a couple strings. Really nice progress, Pog. Thank you. Thank you. I think we're getting close to something interesting, for sure. Where before we were not very close to something interesting. For sure. Why is this not working? Oh, did I fucking forget to run this on the... No, this is device CUDA. Why is it so slow now? Oh, because I export. And I wasn't running on CUDA, which is why it was so fucking slow. Oh, beauty. Beauty. Okay, let's look at the combined metric. Combined. I do kind of like that. I should have preserved the old version. So maybe we'll pass in a parameter here that's like weight. And we'll multiply this by weight. And the weight will, by default, be 1.0. And wherever we call this guy, combined scores for samples. And this will now instead be a lambda that takes in x and y and runs this with x, y, and weight equal to 0.2. Yeah. Combined 0.2. Okay, and then we will just do a bunch of these. 0.2, 4, 6, 8, 1, 0. God, that's gonna be so sick if that actually works. Sick. Dude, sometimes the payoff is nice. You put in work and you don't like what you did, but then now we have this sick, like, 0.2, 0.4, 0.6, 0.8. So definitely at like 0.8, we start to see some like shitty stuff in the corners here. 1.0, absolute shit. So, but like, what if we wait at like if we tried to like weight our brightness at like 0.4, that actually starts to look kind of okay. Maybe like, it looks like maybe it's like 0.4, 0.5 isn't like a crazy bad metric. That looks decent, I would argue. It definitely, there's some things in here that don't like mimic the original very well. Like, I don't know why this little shimmer is in here and like this doesn't look right, but it does look like, while we might not say that it looks accurate to the original, I think it looks like good. It looks like something. Okay. So the other thing I wanted to look at is we could try blurring the glyphs after we render them. And that could be something like that gives us like locality and brightness kind of like in one shot. So let's look at blurring. So if we were to like blur each of these glyphs, I think that's like something very similar to the brightness plus diff metric, except the diff metric, as in like this pixel compared to this pixel in the glyph, this pixel in the sample compared to this pixel in the glyph, it would then like actually start to say, if in this case where we had, we were talking about the case earlier where we have an X in here that's offset by a little bit versus like the glyph where it's centered, right? Now all of a sudden, like if we blur this guy so that he looks kind of more like fat and like grayer, maybe we would start to like say, okay, like a slight shift is okay and like a not very slight shift is not okay. You could also imagine maybe like another option would be dilating. You could dilate the glyph, or maybe, yeah, I could imagine dilation be good, but let's start with a blur. And so let's look at these things called image kernels. I don't know if you guys have heard of these. These are super, super useful. So the idea is you take an image, say you have like, you know, your little like, actually we can just use X again, whatever. And say that we have like 3 pixels, well, 3 by 3 area of pixels here. This is 9 pixels. These image kernels, they do these things called like convolutions, which are essentially just the output at this location on the X, right? Like say this is the same thing. It will be some combination of weightings of this grid over top. So like if you put like if you put 1.0 in each of these boxes, you basically say like this pixel is going to be 1 times this plus 1 times this plus 1 times this plus 1 times this plus 1 times this. And so for a blur, you can do something like weight towards the center and to say like I'm going to be like 1.0 times the middle plus like 0.5 times the outside. And you'll get like some of the outside pixels will like bleed into this one essentially. And there are like a few examples of this. So identity, right? You have 0, 0, 0, 1, 0. This basically says nothing changes. We're only going to look at the center pixel. But you can do something like a box blur, where you say, I'm going to take each of the outside pixels and treat them as the same. Like treat them, like blur them into my thing, essentially. So then you can go from like this to this, right? And that's called like a convolution, essentially, is like this multiplying each pixel by each pixel, essentially. And so what you can do is you can essentially run this 3 by 3 thing over the entire image and run it for like each pixel, and then you just like get an output that's transformed in some way, which is actually a super, super useful concept in machine learning in general. What a lot of these like image classifiers do is they actually create these like image kernels, and they don't say like, I'm going to do an edge detection or I'm going to do a blur. They just say, hey, neural network, fucking figure it out. Like, I don't care. Just like do some sort of image transformation. I don't know what it is, but you figure out what the image transformation is and then use that transformed image to make your prediction. And that turns out to be like a very like effective way to extract features in an image that are useful to the neural network. But we can try one of these. So let's just try just doing like a simple box blur. and see what that looks like. So for now, I think what I'm just going to do is where we render the glyphs on the page, we can actually just do one of these convolutions ourselves. So we can say that Torch has a way to run these convolutions for us. Because if I wanted to take this like 3x3 thing and run it over the whole image in Python, that would be slow. You need some sort of like fast iteration mechanism, which Torch has for us. So I think it's in from Torch and then functional import conv2d, which is basically like run this 2D convolution. And I think I have to look up the documentation for this. Functional Torch here. So his input is mini batch in channels height width for eyes image, I think probably, or input maybe. The weights are out channels. So our in channels and out channels are both 1. We're working with like a black and white image. In channels over groups. I don't know what groups are here. So I'll have, but I think this is probably just 1 for us, and then kernel width and height. So we can make for our little box blur, where the fuck we just were. Where were we? We were at get glyph, here we go. So if we want to do a box blur, we should create a kernel that's just all 1s, like we saw here. Our box blur, they also divide by 9 because you want like the output pixel to be in like the same range. So if you added up 1, 1, 1, 1, 1, 1, 1 here, you'd end up with like a 1.0 turns into like a 9.0. So you divide by 9 to get it back to the right thing. And we can say our kernel is torch 1s in the shape of 3x3. But like we saw in this documentation, they need a couple extra dimensions here. So we're just going to put 1 by 1 for those dimensions because we don't really get them. And hopefully that just works out. These are going to be floats. And they are going to be on the device of the image. Right? Because if the image came from the GPU, we just need to make sure that we like stay on the GPU. Then we execute our conv2d. So we say image is equal to image conv2d image, but this image also has to be in 4-dimensional input. So we have like, we want 1 by 1 by height by width. So we say height is equal to image shape 0, width is the image shape 1. And then we can say the image, what am I trying to do here? I already forgot. Right, I'm trying to do image reshape 1, 1 height width, then pass in the kernel. And what is the output here? I actually don't know what the output is, but I guess we'll find out in a second when we try to run this, and it's fucking broken. So I forgot a bracket here. Brackets are hard life. And let's take a little peek at our labels. Fuck. Refresh. Refresh. Okay, so all of these aren't working, and the question is, why? Cannot handle this data type, 1, 1, 24, 12. So it looks like this came out as 1, 1, and so we just have to reshape this back into height width, like it is expecting. And hopefully then it works. Open image in new tab so we don't fucking spam it. Refresh, 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 refresh. 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 Okay, what's happening now? 2412 is invalid for the size of 264. 24 times 14, 336. So we're expecting an image that's bigger. Oh, fuck. Hold on. So I think what they might have done is like on the edge of the image, they're basically like, if you want to end up in the same size, you would have to run your kernel kind of like outside the image. And they probably just didn't do that. So what did they get? If we reduced our height and width by 1 on each dimension, which is probably what would have happened here for a 3x3 kernel, we would have what, 23 times 13. Minus 2 on each side, 22 times 12, 264. Yeah, so it looks like we need to pad the image probably. That's my guess. That's my guess. So I think I saw, when I was at the documentation there, I think I saw a padding parameter. Stride as well. So stride is 1 by default, which is reasonable, right? We're not jumping multiple pixels at a time. We're only jumping 1 at a time. But the padding, we just need to like put the outside. Just I don't know what it's gonna do there. Presumably just dark, but we'll see. I guess we can also just say height -2, width -2 temporarily, just to see what it looks like. I think that should give us an image that will at least come out. Refresh. Okay, so that gives us something. And now let's refresh our labels here. Hey, okay, so here we've got a pretty clearly fucked up blurred thing. I forgot to divide by 9, which is important here, because everything's just like way too fucking bright now. We have to wait for some of this like pre-generation of all of our different levels of combined. Oh, okay. That looks okay. I might want to run it a couple times. Yeah, I might want to run it a couple times. And let's try with the padding as well. Instead of reshaping to height -2, width -2, let's try padding it and see what that looks like. So 1 padding, I think, should keep us at the same width and height. We have to give this a sec. Refresh. Yeah, that looks okay. My suspicion is that I want to see it blurred a little more. So we could either do a box blur with like a larger radius 1 time, or we could box blur twice. And I think probably if you were to do the math there, box blurring twice would weight towards the center, and doing a larger stride once wouldn't, I think. I saw on this Wikipedia page when I was reading it earlier, or maybe not this one. I was trying to look up, like, there's this, like, Gaussian blur, which basically weights towards the center pixel, and box blur. And I think I was reading maybe here that running the box blur multiple times approximates a Gaussian blur by central limit theorem. I don't know what central limit theorem is, but you could imagine that, like, you're kind of, every time you run the box blur again, the stuff in the center probably would stay about the same brightness, and the stuff outside would bleed more, I think. I think I could, like, convince myself that's true without actually, like, thinking about it too hard. And is that what I want? I think I want just kind of, like, more infection of the surroundings. So let's do a 5x5 single pass box blur, which we now have to divide by 25 because the total brightness has changed. And our padding now has to be 2 because our kernel is going to go farther outside the image. I think. I think. We'll see. What's also kind of interesting here is that, like, everything's going to turn kind of gray by doing this, which I'm not really sure is what I want. Maybe it is, right? If there's like, if there's like a lot of white, the white in the center should still stay there, and it's only where there's like lots of differences between white and black where they will be turning gray. So I think that's pretty reasonable, actually, probably. Okay, I think that I'm okay with like a 5x5 box blur here. That looks decent to me. Let's actually let's try running an algorithm, like a diff metric with the blurred thing. So we can just copy paste this blur. In theory, we should do this in advance, right? Doing this every time we compute a label is like fucking stupid. But oh well. And so what we can do here is we can then say we're going to go to our image sampler, which is where we're doing our label generation, and we can actually just copy paste this scoring function that does the diff of the two. And we can say get blurred diff scores for samples. Computing the blur every time is like kind of stupid, but that's okay. We're just gonna eat that cost for now because I just want to get something working. And okay. So what do we have here? We want to adjust this so that our image, they said they want it in batch. We're going to look at this again. Batch in channels height width. So here we're going to change this to n. We have n images. No, C. We want to do this for each glyph. Yeah. So blurred glyph cache is equal to the convolution of the glyph cache, which has C characters, which are now reshaping into C1 height width. We're going to apply the kernel with padding, and we're going to shape this back into C height width. And then anywhere where we use, here when we subtract the glyph cache, we just subtract the blurred glyph cache. And maybe that'll work. So here, we're going to make a new one. A new option here, blurred diff. We're going to call it get blurred diff scores for samples. Maybe that's it? Maybe? I'm not actually sure. And I guess in our, when we look at each of the glyphs, we are blurring them, but we can leave them blurred for now. I think that's fine, because that'll give us like a better intuition on this new metric. Certainly this won't run correctly. Yeah, because they're wanting device as image.device, which is wrong. This should be glyph cache device. All right. Looks like it ran, which means that now we should be able to refresh, and we should be able to look at the blurred diff versus diff. All right, that looks kind of okay. Maybe not quite the way I would like, but here we're keeping some shape here that we haven't seen in any of the other versions, right? Like, if we look at combined brightness and... This is the brightness and... What was the other one? Brightness and, like, raw diff metric. Here's the blurred diff. The blurred diff definitely feels more like the original image, in my mind. This has, like, a lot of, like, white in it. But the blurred diff does not. And I'm pretty sure, let's just like open this again and like zoom in. Oh, fuck yes. Okay, this is exactly what, this is so cool. Okay, so they're basically using dithering here. We've just like let the labeling metric learn about dithering by blurring. That's so sick. Which kind of means that we're kind of losing a lot of like the like ASCII nature of this. But that's, I think, definitely the most correct answer. Right, like, it just makes sense to use these characters almost exclusively. And the only time it's not is when it has, like, rounded edges to take care of, which is pretty interesting. I'd like to try a smaller blur. Let's try 3x3 with 1 padding. Oh, hold on. Oh, yeah, that's right. I just want to see if that's any better. And in reality... Oh, fuck. We should maybe allow us to look at both at once. So we're going to say that the kernel size is equal to 3 here. And here we're going to pass in kernel size. And here we're going to say kernel size time... divided by kernel size. We're going to square it because it's width by height. And the padding is... I actually don't know. Padding is the kernel size minus 2? No. Let's draw it out. So if we have 3x3 we have this goes off the top left. If we have 5 by 5, 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, we have this and this is going off. So adding 2. So this is 7 would be 3. So it's minus 1 over 2, I think is the padding size. Padding is equal to kernel size minus 1 divided by 2, I think. And this will only work if the kernel size is odd, but we'll just not pass in even ones for now. Okay, cool. So now when we go back into our... Where were we? Visualize. We can try to both a blurred diff 3 and blurred diff 5, and these will now take lambda x, y, and this will pass in x, y, and 3, and this will pass in x, y, and 5. Easy. And let's just reduce computation by deleting some of these ones that we knew we didn't care about. We only like to combine 4. Maybe we like to combine 6 as well, actually. Just to save a little computation for us, you know? Oops. That's a mistake. What'd I get wrong? Interesting. Does it work without CUDA? It's hard to tell because it takes so fucking long in the CPU. Holy shit. Holy hell, man. It does look like it ran on the CPU, though, which means that maybe print kernel and padding. Let's just see what we got here. We'll run it with CUDA and see. We might just need to be a little careful here. So we have kernel is floats. Padding is 1. It's weird that padding equals 1, I think did work here. Oh no, it still doesn't like that. Why is it different now? Oh, maybe because kernel size used to be a float and now it's not, and maybe it like that confused it in some way. That's possible. No, that's weird. I don't know why this would be any different. Because before we had 3 divided by 9 and padding equals 1 like this. We had it all hard-coded. Oh. That's weird. That this used to work and now it doesn't. Am I high? Is it about this like export? No? That's weird. I swear we didn't change anything here. That's so frustrating. And we probably didn't save anything either. We can probably just undo a lot here. Right, this is where it worked. Does it still work if we do this? We just have to take in a padding or kernel size here, even though we're not using it, just so that the code lines up. Huh. Maybe my GPU just like got into a fucked up state. That's annoying. But we live. We learn. So we'll go back to... I guess we'll just run it on the CPU and just tank the computation cost. It's annoying. And I lost the code that we wrote, so we just have to rewrite it. Kernel size, divide by kernel size, and then we had padding is equal to kernel minus 1 over 2. A more elegant way would be to take the floor of kernel size over. Yeah, you're right. Sure. That works for me. padding, and we'll just write padding here. And I guess we'll just fucking run on the CPU, which means that in our visualizer, let's just like comment out some of these functions so that we have less computation to eat. Fuck. Could you explain how your metric is working? Like, how do you check if a glyph matches a pixel region? It's very interesting. So all I'm doing here is so here we have our inputs for this. Fuck. Only one element tensors can be converted. Oh, oops, this should be kernel size. It's very interesting. Okay, so how do I explain this? Here are two inputs are a glyph cache, which is number of characters by height by width, so each rendered section, and the samples are just sections of the image that are the same size as the glyph, right? All we're doing is subtracting for each sample, for each glyph, subtract one from the other. And now what we're doing when we're adding this blur in is just before we do that subtraction, we just blur the glyph a little bit. And that adds some sort of like locality that isn't like perfect locality. So this is with a 3x3 box blur. This is the 5x5 box blur. I don't really like either one more than the other, to be honest. It would also be interesting to look at like the 24 pixel wide version, right? Like we're using a lot of characters here. It'd be interesting if we have less, if we get like a different result. Gotta wait for our CPU to crunch again. Look at the blurred diff with a 3x3 kernel. Wow, that looks like ass. Absolute shit. This also looks like absolute shit. Okay, let's eat the cost on the CPU to bring back everything, because I actually do want to know if these other metrics look better for a fatter glyph. In fact, we should probably look at all of these combined to 4, 6, and 8, and 1.0. I think it's worth it. I need to know. I want to know. Every time I say I want to know, I think about Disney's Tarzan from like 2002. What year is this movie from? 1999, even earlier. Bill Collins, he's saying that he wanted to know. And I think about that every fucking time. Are you a PhD student? No. I barely got my bachelor's degree. I was very close to failing out, actually. I had to do a psych requirement at the end, and I just did not give a fuck. And so I got like 20% on the final exam, and when I handed it in, like the TA chased me down in the hall to check if I was like okay. I think she thought that I was like maybe gonna go home and do something stupid. I was fine. I told her I got what I deserved, because I did get what I deserved. I didn't study, but she thought that meant like I didn't, I got what I deserved, like in like a bad way. And I was like, no. Like I got what I deserved. And she did not think I was okay. But other than that, yeah, just a bachelor's degree. I would think that like working and learning and just trying stuff, I think is like more effective for myself. I'm sure that there's things that I haven't encountered in the real world that like school would allow me to, but overall I think that if there's like stuff you're interested in, you can figure it out. That's my take on it, at least. I actually do think that at this resolution, this raw diff I think looks nicer than the blurred one. Right, this looks like pretty shit. But it could just be that like the blur is too aggressive. We could try like a Gaussian blur and see if that looks less aggressive. Like, right, because the box blur, he's going to like equally account for everyone around him, but maybe the Gaussian blur would give us something that's still like a little more weighted towards the center. So let's try that. Let's comment out all this shit because it's eating my start time. Pain in the ass, for sure. And let's look at the box blur that we're doing here. And can we generate a Gaussian blur? Let's look at like those like image kernels. I know that there's like a way for us to pull in real like how do I say this? Like Torch Vision has these built in, but I refuse to use them because there's no good reason. I just don't want to. So let's make a 3x3. He's gonna be, I guess, can we just like make the array? Tensor, can we just like make him from this manually? So we can do 1, 2, 3, 3x3 kernel. This is gonna be 1, 2, 1, 2, 4, 2, and 1, 2, 1. And we'll call this 3x3 Gaussian blur. And the data type here, I guess we have to close this bracket, and the D type is going to be torch float32, and the device is going to be the glyph cache, what do we call it? Image.device. Cool. So everything's in the right spot. And then we need to divide this guy by 16, I think you said. You just sum all this up. 1, 2, 3, 4, plus 4 is 4 plus 4, 8. Jesus Christ. 8, 9, 10, 11, 12, 16. Yeah, divide by 16 by now. All right. Padding, we had a 2 here. Padding's 1 now because it's a 3x3 kernel. And I think that should be enough for us to be able to like at least see what we want to see. Nope. Weight should have at least 3 dimensions. Right, because this needs to be kernel reshape. What was it? 1, 3, 3? 1, 1, 3, 3? 1, 1, 3, 3. Which I don't know why. But it is what it is. Refresh, baby. All right. So this is a Gaussian blur of a 3x3. Fuck, I should have kept open the box blur version. Because I can't really tell the difference. But, you know, we can just do, you know, fuck it. Fuck it. Fuck it. We can just run the metric and see. Instead of trying to look and infer and use our brains, we could just, we just copy paste. And why think when you can copy paste? That's what I always say. Okay, so we're going to make another version of this. This is the box blur. And we're just going to call this a Gaussian blurred diff for samples. Do I want to like have a configurable size here? No, that sounds hard. And why do something hard when you don't have to? I'll just hard code the kernel here. Copy, paste. And padding is going to just be 1 unconditionally. And I think everything else in here is just the same as the box blur. So let's go back into our versions here and let's look at the box blurs as well as the Gaussian version. And we have no third parameter here. And let's keep the raw diff in there as well. And runner. Take a little peek. Image is not defined because this should be glyph cache, not image. That's the problem with copy pasting, is that you you have to think at least a little bit. All right. So it looks like we're running. So we have blurred diff. Oh, fuck. We have the same, fuck. Gaussian blur. 3. Oh, I have to eat the cost again. What a hard life. Hard life we live sometimes. Give it a sec. Give it a sec. All right. Blurred diff 3. Looks like absolute shit. Gaussian blur 3. I think they just both look like ass. The Gaussian one I think looks like very, very, very slightly better. I guess we don't have to copy paste the Gaussian blur from Wikipedia. Who's to say that Wikipedia is the source of truth? You know, well, it's a pretty good source of truth. It's decent. But we could just do something else, right? What if we just divide all these numbers, right? Fuck it. So instead of doing like so it looks like what they're doing here is every adjacent pixel is like weighted at half, right? The thing to the right is weighted at half, and the thing above the thing to the right is weighted by half again. So what if we just did weighted by 3, right? So we divide this by 3 here. This goes 9, 3, 3, 3. And we can actually just divide by the sum, actually. Kernel equals divide equal by kernel sum, right? Because we want it to be 1, so we actually didn't have to do any math. We could have avoided thinking a little more. And I guess, do we want to compare to the 3x3 Gaussian blur? We don't really care. We know it was still shit, so we'll just run it like this. And we're not ready yet. We're not ready yet. We're not yet. Refresh, 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 refresh. And he's loading like a million pictures, so we'll give him a sec for that. And let's look at this. I think that's looking better. So we could probably like infer here that the more aggressive our Gaussian fall off is. I don't know if that's like the word, but like the steeper the slope of our thing. Hey, the maze finished. Nice. The steeper the slope, the more it will fall back towards this behavior. And so, interestingly, we can kind of see here that this is still like pretty aggressive. Can we look at like, if we look in this area for like the diff version, we're getting like all like basically darker winds, right? But for like this version of the blur, it's actually like a lot different. So maybe we can just push this a little farther, right? Like we can just push this until we see something that's like just a little bit less. So let's try 25, right? Get aggressive with it. And we actually don't need to compare to the box blurs anymore because we just know they're bad. And we probably do want to compare to like the raw diff. At least a little bit. At least a little. I wish that I could still be using my GPU here so that we could like have them all up at once, but it is what it is. Oh, that looks sick. We're actually still missing. What I really liked about like just raw diff is that we're getting like this kind of shape, this feature on the mountain here is being like tracked pretty well. Let's look at like this Gaussian blur. It's interesting that such a minor blur is having such a major impact. It almost makes me think that there's a bug. Because this shouldn't be doing a lot, right? Let's just quickly do the identity version. Just to make sure, because I suspect that there's something weird happening here. That's my suspicion, because it doesn't feel right, you know? And I don't have any like real reason to say that other than just like my gut says it's wrong. Right? Like, no, okay. So when we use identity, it is still tracking very well. What's like the width and height of our sample here? Is it just too small? Print. Oh, we don't have to print. We can just open this. Open image in new tab. Like, this is a 14 by 24. So it could just be that the blur is just guaranteed to take up too much space. So what if we increase the font size? If the font gets rendered bigger, then we can blur less and have less of an effect on the surroundings. That seems reasonable. So here, when we render all of our images to pictures with free type, we say, I want to be rendered at font size 24. Fuck it. Let's go 36. And let's just see if that looks different. I should have left the blur in, fuck, but whatever. Whatever. Refresh, 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 refresh. There we go. Fuck. Okay, let's... That actually doesn't help me at all. Let's put these blur values back. Give it a sec, give it a sec. Boom, 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 boom. All right. Refresh. One more. One more. One more. Come on, buddy, you can do it. Oh, that looks better. Oh, hell yeah. Wait, that actually looks fucking sick. Compared to this, that looks so much fucking better. The padding might be messing it up. Almost certainly, right? Like, because we're going off the edge and I don't really know. We might have to like manually think about the padding ourselves, right? Like, it's possible that we should... I don't know if you want to like extend the outside to just match the color, or if you want to like put in zeros, or maybe it's okay to like shrink down, like apply the blur and get smaller. Maybe that's okay. We'll think about it. But I am starting to like this look. This look is pretty fucking sick, right? This like tracks like this feature here very well. We still have like some visibility of like this thing here. That's still in here. Yeah, it looks fucking sick. On the terminal, it probably looks a lot shittier because I think that the font we're using on the terminal is not the same as the font we're rendering in the picture. It's up here somewhere. But that still looks pretty good. That actually might look better. All right. All right. I think, you know, surely we will have to do some more iterations here. But I think that this is I think I'm happy to continue forward with this metric, at least for a little bit, and kind of see how it looks. And maybe I'm just saying that because we're at the 2-hour mark and I want the video to end, right? Could be. But I also think it looks pretty sick. So where we ended up was aggressive Gaussian blur, more aggressive than Wikipedia told us to, as well as with like more pixels in the font itself so that the blur affected less relative to the size of the glyph. But yeah, that looks sick. Clearly also there's like a bug here, right? Oh no, wait a second. I was gonna say there's clearly a bug here because we're seeing banding. But we actually don't see that when we open... Am I high? Open image in new tab. Oh no, we do see it. Okay. Like, clearly this is a bug, right? Like, whatever's happening here, that's not correct. So we're probably gonna have to eventually do some like fixes to the font rendering itself. But yeah, for now, that's pretty sick. That's kind of cool. Look, you can see it like picking like... That's so cool. It's like picking shapes that match the contours of like the picture. That's so sick. Can we look at like the bottom left? Like, is this? Yeah. Oh god, look at that. Oh, that's beautiful. When I like move up here, it's like picking characters with like more white pixels on the top half. Oh, that's so sick. All right. Sorry. Okay. Let's just say we're happy with it for now. And we have some improvements to make that we know we're gonna make. But probably next stream we'll probably try to train it. I don't know. We need to come up with some way of like comparing success of different neural network strategies, as well as like, yeah, success is going to have some form of like weighted like sum of speed, as well as accuracy, right? So clearly we could just take like a normal image classifier and run it, and it would do a great job here. But that's probably more expensive than just running this ourselves, right? The end result here is that we want whatever we come up with to be faster than generating the labels themselves. So we will have to think about that. I'll probably think about that next stream. We're gonna have to compare like speed, training, all that. But yeah, I think that's next stream. So thanks for watching, guys. If you liked what you saw, I stream most days at around 1 or 2 Pacific time, for around 1 or 2 hours, depending on like the content and how much work there is to do. If you miss a stream, there's a YouTube channel linked to the Twitch description where all the VODs go. If you're watching on YouTube and you want to come tell me why what I'm doing is fucking stupid, feel free to click on the Twitch link in the YouTube description. Code is up on GitHub, so this is the same username as both Twitch and YouTube. And I will probably clean this up hopefully today and post what we have so far on here. This is up to like label visualization, so hopefully we get up to loss metrics will be the next commit that goes here. Yeah, that's it. Thanks for watching, guys. Catch you on the next one. Bye.